This video will show the solutions for questions 8 through 12 from the Chapter 3 review exercises in the ebook. So this series of questions is about elasticity of demand, and on the test you'll be given this information. You'll be told that demand X is a function of price, and you'll also be given this information. You'll be told that to calculate the elasticity of demand for price P, you use the formula negative P times the derivative of f of p over f of p. Okay, so question number 8 asks us to express the demand x as a function of price. So if you're expressing demand as a function of price, you're basically just rewriting x to be in terms of p. So solving for x, basically. So that's the first thing we need to do here. So I'm going to take the equation they gave us, and I'll just solve for x. This is just algebra, no calculus is happening here. So I'm going to subtract 2p on both sides of my equation. Okay, and then I'll divide both sides by this 0.01. When I do that, that'll give me a plain x on the left, and then I had a binomial on the right, and both of those pieces are being divided by this decimal value, so I can split that into two fractions. And then I'll just go ahead and use my calculator real quick. So doing that, I got x is equal to 5,000 minus 200p. And again, x is a function of price. So instead of an x, I can write that as f of p. And then I can see my rule here on the right-hand side is in terms of p. So if I know the price, I can plug it in to this rule and calculate the demand. So 9 asks us to find the elasticity of demand, the E of p. So that's using this formula up here. And for that formula, we need to know f of p, which we just found. And we also need to know the derivative of that function. So let's go ahead and find the derivative of f of p real quick. Well, p is just acting like an input variable. So keep that in mind. That means if we have the derivative of p somewhere, it's going to be a 1. P is a just normal everyday input variable. So when I take the derivative of the right-hand side, 5,000 is a constant, so that'll be a 0. And either you might see that the derivative of negative 200p is just negative 200. If not, you'll do your chain rule. So let's go ahead and do the chain rule on this one. There's an understood exponent of 1 there on my p. I drop my exponent down. So 200 times 1 is 200. So I'm subtracting 200. I rewrite my base. I decrease that exponent by 1, so now my exponent's going to be a 0, and I tack on the derivative of the base. But again, any non-zero base to the 0 power is going to be 1, and p prime is also going to be 1 since p is an input variable. So 0 minus 200 times 1 times 1, that just means that my f prime of p is going to be negative 200. So I'll go ahead and write that down there. And now we can find E of p. So E of p is negative p times the derivative, which we just found was negative 200, all over the f of p function, which was 5,000 minus 200p. And I can simplify that numerator. Negative p times negative 200 is just going to give me 200p. And you can stop right here. You don't have to do anything fancy. Now, my math lab will factor out a 200 in the denominator. They'll simplify this a little bit, but it's completely not necessary, but I'll go ahead and do it. So if I factor 200 out of 5,000, that'll give me 25. And then if I factor 200 out of negative 200p, that leaves me with a negative p. And then those 200s will divide to 1. So my simplified version of the elasticity calculation will be p over 25 minus p. But you'll get the exact same answers whether you use the unsimplified rule or the simplified rule. And I'll count either one correct on a test. So now that we have that calculation, we can answer question 10. Question 10 asks us to do two things. The first thing is to find the elasticity of demand when price is $15. So I'm just going to plug 15 into my elasticity calculation that we just came up with in number 9. So that gives me 15 over 25 minus 15, and we'll get a decimal value for that. So we get 1.5. Now 1.5 is greater than 1, which means we're in an elastic situation. In an elastic situation, that means that our price increases or decreases has a big effect on demand increases or decreases. It's more volatile situation. We say that demand is very responsive to price. So a little change in price has a huge impact on demand. So let's see what the next part of the question says. It says, if the price, that $15 price is increased by 5%, what is the approximate percent change in demand? Okay, so we're just going to assume that price and demand are changing in opposite directions. So here my price is increasing, so I'm going to assume demand is going to decrease. Now, since it's an elastic situation, if the price increases 5%, demand is going to decrease by more than 5%. And what happens is we use this elasticity calculation as a multiplier. So the demand is going to change 1.5 times more than the price. So if the price is changing by 5%, I just multiply that by 1.5. And that means that my demand is going to decrease by 7.5%. So if price increases 5%, then we're going to assume that demand is going to decrease 7.5%. Okay, 11 is asking us to find all values of P, so all the prices for which the demand is elastic. So we know one of the prices, it's elastic at $15, so what are the other prices? So to find that, we're just going to take this elasticity calculation, this generic calculation here, the P over 25 minus P, and we want to know the values of P that would make that calculation greater than 1. Okay, so we're just doing some algebra here to solve this inequality. So I'm going to multiply both sides by my binomial. So I'm going to multiply both sides by 25 minus P. Okay, and that will just clear my fraction for me. So P is going to be greater than 25 minus P. And then I'll go ahead and add P to both sides. Okay, so 2P is greater than 25, and then I'll divide both sides by 2, and that gives me that P is going to be greater than 12.5. 12.5. So that's a price of $12.50. Now, if I leave it at this, that's assuming any price bigger than $12.50 would make the situation elastic, but there has to be an upper cap on that price. The price can't be $10 million. There has to be some realistic upper cap. And to find that, we have to go back to the domain of the function. Now, we weren't specifically asked to find the domain of this function in a previous problem, but we're going to need that to find this upper cap on my price. And to do that, we're just going to use the idea that demand also has to be positive. So demand has to be greater than or equal to 0. And remember, demand was just f of p. We rewrote x to be a function of price. So if I just set that f of p function that we created, the 5,000 minus 200p, if I set that greater than or equal to 0 and solve for p, that'll give me that upper cap on the price. So let's go ahead and do that. I'll subtract 5,000 on both sides. And again, this is just algebra. I'm not doing any calculus here. And then we have to divide both sides by negative 200. And keep in mind, when you divide by a negative number in an inequality, it reverses the sign of the inequality symbol. So when I do that, that's going to give me my upper cap of $25. Okay, so that upper cap is set by the domain of this function. So the highest price we can set for this item is $25. So when I come over here to find for which values of P, for which prices is my demand elastic, I need to cap that at $25. That just looks weird. So we would really write it like this. We would really put the lower cap, that $12.50 first, and then we'd put the upper cap on the right side. Okay, so any price between $12.50 and $25 will create an elastic situation. Okay, we have one more question to solve here. Number 12. 12 says, if price is $9 and the price is increased, will the revenue increase or decrease? So if the price is $9, it's not in this interval we just found. So it's not elastic. So we can assume it's inelastic. But if you hadn't done part 11, we would still need to figure out if that's elastic or inelastic. And we can do that by just plugging it into our elasticity calculation here. So I would just plug 9 into my formula. So that'd be 9 over 25 minus 9. And that's going to be 9 over 16. And I don't even really need to get the decimal value for that because it's definitely less than 1. If you have 9 out of 16, you're less than 1. But what is that? That is 0.5625. Okay, so that's definitely going to be between 0 and 1, which makes it an inelastic situation. Okay, and the fact that it's inelastic will tell me how my revenue is behaving. And I've kind of run out of space here and I'm using a different app. So I'm just going to draw my little diagram up here. So you're going to be given this diagram. It's the revenue curve. It'll be cut in half. And if you're in an inelastic situation, you're going to be on the left side of the graph. And that's what we are right now. If you were in an elastic situation, you would be on the right side of the graphic, but we're inelastic. So I'm going to be over here and we're at a price of $9. So you can just pick any point there. So let's say this was $9. Okay. So the graphic is going to help me figure out how to interpret my revenue. So let's see how to interpret this revenue. Okay, so it's saying if the prices increase. So if I increase my price, let's say I increase that to, I don't know, like $9.50 or something. I increase my price. Then I can see that I have to go up to hit my revenue curve. So by increasing my price, I'm increasing my revenue. So what's happening there is when I increase my price in an inelastic situation, that price increase only drops my demand just a little bit. So I'm selling a few less items, but since the price is higher, I'm still bringing in more money. So increasing my price will drop my demand just a little bit because it's inelastic. So I'll be selling a few less items, but at a higher price, my revenue is going to go up. So for 12, will the revenue increase or decrease? My revenue is going to increase in the inelastic situation. So revenue will increase. And just to take a look at the elastic situation, since we're here on the video, let's say we were at a price. What was our elastic price? It was $15. Okay, let's say we're up here at $15. I'm coming back here to number 10, where we found that $15 was an elastic situation. So I'm going to go ahead and mark that on here. Now, what would happen in this elastic situation if I increase the price? So if I increase the price to say, I don't know, $16 in this elastic situation, I can see that my revenue drops. I have to go down to hit my revenue curve. And that's because that little price increase in an elastic situation has a huge effect on demand, or a big effect on demand. So I'm increasing the price, so I'm getting more money when I sell stuff, but my demand went down so much that I'm not selling as many, I'm selling much, much fewer items. So I'm not bringing in the same amount of money. But on the other shoe, if I decrease the price a little bit, decreasing that price just a little bit has a big effect on demand. A small price decrease will mean I sell a lot more items. So even though I'm selling them for a slightly lower price, I'm going to sell so many more of them that my revenue will actually increase there. So this graphic will be given to you and you can just use it to help interpret what's happening to revenue in an inelastic situation versus an elastic situation.